Okay, hello. Today, this is day one of relearning data structures and algorithms, and today we're gonna learn arrays. I'm just trying to relearn the basics. Well, I already know like these kind of basics, like arrays, stacks, queues, and so on. But I would want to go more over more harder topics such as graphs, trees, and hash maps, and you guys could be there with me, so it could be like my point of view, and like you can probably learn from me, but it's gonna be me relearning it, so maybe you guys could take something into account from it, into it, because I know a lot of people you learn with a broader perspective, or like how someone else thinks differently, maybe that would kind of help you. So today we're learning about arrays. So basically here I made a bunch of declared a bunch of arrays, and they're different data types. There's integer, string, char, double, and also this is technically it's kind of like an array. So for example, string my string equals hello there, and then you can get the characters from each string. So for example, my string, let me just see out my string, and then to get the element in an index, for example, this is 0, h is 0, then 1 2 3 4 5, and so on. Same things here, it starts at 0, array starts at 0. So for here we have 0 1 2 3 4, we have 4 elements in the array, but there's 5 in here, you can say. So if we see out, oops, index 0, we'll get, whoops, I have caps on, inline, and save, oops, save again, and we'll compile that, and /a.exe, we get the letter H, exactly. So alright, let's do some basics in arrays. So I'm sorry, I've been using other languages. I don't know if I can for can you use this in C++? C++ for loop, but I want to use the newest way you can do it. I don't know for what version it was. For type. Is that how you go in it? I would want to do this, but if not, okay, that's how you would do it. So yeah, I would just do type int colon comma, what was it? Oops, I did not get that right off. For int x comma arr, right? Wait, oh my god, it's a colon. Okay, alright, we'll just see out the contents of AR of X, or no, just, yeah, right? Or how would this work? See, you guys are going along the right with me. What does that do? 2 3 8 0. That's just a bunch of random. Wait, why is it seeing out a bunch of other stuff? Why don't we just see X? 1 2 3 8 0 0. Oh, that's because I have more memory in here. I forgot. Well, let's just uh, yeah, let's just do the normal for loop. Int I equals 0, I is less than AR. And I'll be looking up more of these different syntax that they've included. I haven't touched C++ in a while, so it's a refresher for me too. Why is it giving me an error? Oh, well, let's just do the actual size. 1, 2, 3, 4, 5 elements. We'll just hardcore the size for now. And then we'll see it out. So see out AR of I. And then let's give it some space. And let's just do a new line as well. Well, no, we don't want to do a new line. And yeah, should be good. Okay, so let's see out. 1, 2, 3, 8, 0. 1, 2, 3, 8, 0. Yeah, exactly. Cool. Let's just put 10 instead. Alright, let's just do a basic. Let's just sum up what we have so far. Well, not sum up. I mean, let's do the sum of what we have. So let's have a variable for storing. So end sum equals 0. Because if you don't declare the the data before, it's just gonna give you some random junk value. So for example, if I don't declare anything, let's just see out sum right here. See out sum. Let's check what we get. -2, like what did I store at -2? Nowhere, right? So yeah, it's better to declare your variables. Not declare, initialize your variables. So let's just do sum plus equals to accumulate the variables. That's how you accumulate without having to write sum equals sum blah blah blah. This is the shorter syntax for that. Sum plus equals AR of I. So it basically 1 0 plus 1 1, and then that's gonna be 1 already. So it's gonna be 1 plus 2 3, and we can also see out that just in case you want to see what it would look like. So sum plus, I mean, not, why am I doing that? Sum plus AR of I, no line, and then see out sum is sum. Alright, let's check what we get. 0 plus 1. Yeah. Well, let's just also do, and then we'll see out the sums. Also the sum. Let's do the space. Sum, and then SN line. And let's put equal. And then, yeah. Just to make it like look how it would actually look like. Let's not end line here. Okay. Okay, 0 plus 1 is 1, 1, and then we store that. 1 plus 2 is 3, you save that. 3 plus 3 is 6, and so on. And that's how you get the sum. And yeah, that's how we do a basic operation. Basic, like, sum operation. Alright, now that we have done that, let's do something a little bit more complicated. So let's just say we want to insert the value 5 here. Now, an easy way would to do binary search, which can be recursively or you can do it iteratively, but I would probably do that in a later video, recursion or iteratively, or doing it with like an iterative solution, because that's a little more complicated. I just want to go over the basics today. So let's just say we want to insert the value 5. So first what would we have to do? Let's think of a solution. All right. So we know it's sorted. It's not really gonna do much for us because I don't want to go that complicated to more advanced techniques. So let's just say we want to insert 5. It would go inside this here, right? So it's gonna be at 0, 1, 2, 3. So this little box or this thing needs to move over by 1. We need to shift all this over by 1. So 5 could be here at index 0, 1, 2, 3. So first of all, let's just do a loop. Int I equals 0. I is less than 1, 2, 0, 1, 2, 3, 4, 5. And then I plus plus, right? Because we're going to stop at 5. So when it's 4, first 0, 1, 0, 1, 2, 3, 4. So yeah, we stop at that index. And then what do we want to do? So if okay, no, we want to start at the end. But I don't think it's gonna matter, right? Because we just have to find the correct index. So we'll have to stop when it's greater than that. Okay. So if ARR of I is greater than or equal to, let's just okay, have x, then we're gonna, let's just say save equals 0 right now. Well, no, we don't want to do anything close to it, right? So save is equal to I. That way we save the index that we need, that we want to insert. So for example, is 1 greater than 5? Nope. So we're going to keep going. Is 2 greater than or equal to 5? Nope. Is 3 greater than or equal to 5? Nope. Is 8 greater than or equal to 5? Yes. So we're gonna stop there and we're gonna be at this position. So save is equal to I. And now that we have the correct index, so basically we're gonna be right here at this index. We wanna shift all these values over by 1. So that would require another for loop. Int I equals 0. I is, well, we want to start at the top, so 0, 1, 2, 3, 4. I keep forgetting how many elements we have. 5. So we want to start at 5 or at 4, doesn't matter. And then, well, I is greater than or equal to 0. We want to decrement the count, the I index. That way we go down. So basically, we're gonna start here, and we're gonna decrement. But since we hard coded more memory slots into this, it technically has 9 indexes, which we can't see, but they're all gonna be zeros, and we just shift everything over. So yeah. While we won't, no, actually, we want to start at 5. No, at 4. Yeah. Okay. So we basically want to swap. Actually, we want to start at 5. That way we can swap 5 in that. So we can either do this. I'm gonna just show you guys the swap function. That's already using the C++ STL library. So we want to swap ARR of I with AR of I minus 1, right? So basically it's swapping 10 and whatever's over here. So it's going to be 10 dot 0, whatever elements there. And then we're going to get to here, it's going to swap 8 dot. So now it's going to probably be some 0 slot here, and then we can actually now insert that value that we want to, because now we don't need this no more. Everything's in place, everything's still in order. So well, int ARR of our index save. Remember, we saved the index. We can actually now insert our value into it. So if we do another for loop, so let's just copy this for now. So I don't have to rewrite the whole thing. I is less than 0. I plus plus. We're gonna see out AR. Let's just do a little this so we can see a little how it would look like in an array. And then let's just not do that thing here. And then ARR, ILI. And then close the brackets. And let's give some space in between each. And then, yeah. Okay. Let's check if we actually get 1, 2, 3, 5, 8, 10. If not, we'll debug in person, in video, no cuts or anything like that. G++, let's compile. Okay, what's going on? Why is it not seeing it? Wait, what? Oopsie daisy. I'm sorry. I was like, what? Okay, that's not the value we want to see. What happened? Wait, okay, let's actually debug this in person, in live video. So, while I is less than, when I is 0, I is less than 5, I plus plus. It should be 4. I plus plus, if array of I is greater than or equal to x, so is the array of 1 greater than or equal to 5? Is 1 greater than or equal to 5? No. Da 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 da. Wait, what? 1, 2, 5. 1, 2, 3, 4. Wait. Oh, okay. 1, 2, 3, 5. Oh, I forgot. We need a, what's it called? Okay, so you can see it's clearly in the right order. We're just getting some random junk value in the beginning. Well, let's just do a break here because we don't need to be there no more. Because it's gonna be searching all of them, so of course it's gonna look at 10. So, okay, still giving me that junk value. I'm debugging live with you guys. Okay, so okay, we're looping to the size. Yes. We found it because we start 0, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Yes, that's correct. We're getting the right index and everything. Oh, we should need to increment the size by 1 because now we have another value. Wait, no. Why is it giving me that junk value? Okay, what is happening? Why are we... Wait. Oh my god, that makes so much more sense. Okay. Good thing we're doing this live. We need to do this until we get to the save position. Because why are we going to swap that part, right? One, what? Wait. 1, 2, 3, 5, 8, 10. 1, 2, 3, 5, 8, 10. See? And we did this with live debugging. Okay. So basically, alright, let's just break down what we did. So we don't need this. Just okay. So let's just comment code. Declare number to insert. So that's pretty self-explanatory. Save index to be inserted. So we just want to store the value that we want to insert. That way we can actually stop at that one. And then find index, find correct index logic, right? So we're looping through this array, and then we're finding if our number is less than or equal to that. So in this case, it's greater than or equal to, So in this case, it would be, what do we get? 5. So 5 would be the one here. And we want to break, this is basically going to break from the for loop because we don't want to go through all the other elements anymore. Because 10 would also be greater than or equal to 5. So that's one thing. And then here, we're basically, since this has 4 elements, 1, 2, 3, 1, 0, 1, 2, 3, 4, or 5, if you will, we're gonna want to start at index 5, so over here. So basically it's 1, 2, 3, 8, 10, 0. So we want to start at index 5 here. We want to swap these, and then we're gonna swap, and then and then we're gonna swap this, and then we're gonna say that, and then we're gonna stop at this condition, right? Because we're starting at index 5. So let's just go through the numbers. So swap 0 and 10. Okay, so we're gonna swap 0 and 10, and then we're gonna decrement, so now I is gonna be 4. So we're gonna be here is 4 and then is 4 less than save, which is gonna be 3, 0, 1, 2, 3 is no, right? So we're gonna keep going. We're gonna swap these two, so 0, 8. Yep, 0, 8, and then we're gonna be at index 3, 0, 1, 2, 3. So now we're at that condition, but it's not gonna go to it because it's already less than 3. So that's when we're gonna exit, and now we have this 1, 2, 3, 0, 8, 10. And now, since we already saved the index, and this is just a value we don't need no more, we're gonna just insert it. We're gonna insert 5. So 5 is inserted, and basically this is just another for loop, and we're just displaying it nicely. And remember, we had to do more. We had to increment the size because we added another element. So before we were just doing 4 because there was 4 elements, but now there's 1, 2, 3, 4, 5, 6. Not 4. There was 5 elements, but now we have 6 elements. 1, 2, 3, 4, 5, 6. So yeah, that's how it basically works. And we did live debugging. There's gonna be no edits in this video, as you can see. So yes, goodbye.